Most service technicians know the situation. They know because sooner or later, the customer, the tractor, and the service concern land right at the service department's doorstep. And when it happens, any good technician wants to give a customer the best possible service.
Sure is, Frank, but it'd be a lot nicer if my tractor had some power.
Having power problems, eh?
Yeah, doesn't seem to be able to pull the way it used to.
It's been doing that long, Jim?
Oh, just about a week now.
Have you looked at your fuel filter?
Yeah, I just changed that.
So a good
Tuesday.
tech gives the situation a quick appraisal and makes a decision.
Sounds to me like it could be your fuel injection pump, Jim. We can take the tractor inside, check the pump out, put your rebuilt one on if that's the problem, have you back in the field and by this afternoon.
Well, if that's what you think, Frank.
Then it's off for a wrench because there's only one way to take care of it. This tech knows a fuel injection pump is a complex device. It should be serviced only by specialists with the proper test equipment and adjustment tools. No attempt should be made to work on a fuel injection pump in the field. Unless, of course, complete repair facilities and specially trained personnel are available. So, if a thorough fuel system diagnosis shows a malfunctioning pump, the solution is to exchange the pump. But wait, we're talking about a thorough diagnosis. This tech is about to send back the pump, but apparently without a system diagnosis. Is the pump really to blame? He could be creating an unnecessary cost for his customer, and here's why. The pumps are sent back to Ford for exchange. The old pump is examined to find the difficulty. Then it's rebuilt. Meanwhile, a rebuilt or new pump is obtained from the Ford parts depot for replacement on the tractor. The cost could be several $100s for the owner. Lucas CAV, the injection pump manufacturer, has been investigating a quantity of original equipment pumps sent in from the field at Ford's request to see just what's wrong with them. After looking at quite a few, they've made a startling discovery. Many of these pumps have nothing wrong with them, no malfunction at all. Yet each one returned with nothing wrong means unnecessary expense for someone. Some pumps are returned with legitimate concerns. Other pumps have malfunctioned because of water or dirt in the fuel. But if a pump is not malfunctioning, the concern must be somewhere else, either in the fuel system or other engine components. If that's the case, a new pump won't fix the concern. It's just a costly and unnecessary parts replacement. If the pump malfunction is caused by entry of dirt or water, that means it can reoccur again, even after a new pump is installed, possibly at a later date. Certainly, that's no way to keep a satisfied customer. To help avoid the situation, this Trac Com video program presents some causes of fuel system concerns and illustrates how to diagnose them. We'll help identify damage caused by contaminants in the fuel and offer some preventive maintenance suggestions for fuel systems. We'll begin by a look at the diesel fuel situation for tractor owners. Since 1972, the sharply rising market for diesel cars and trucks has inflated demand for diesel fuel. Combined with decreased supplies of foreign crude, the demand has lowered the quality of tractor fuel. Let's look at a chart showing a barrel of crude oil to see why. Fuel used for automotive, truck, and air transportation comes from the #1 band of crude oil. Rising demand forces refiners to dip into the #2 band used for diesel farm machinery. Poorer quality residual portions of the barrel are then used to maintain supplies of the #2 band. Inherent in the lower quality fuel are lower cetane ratings, higher sulfur content, a higher cloud point, and greater water retention. In short, the fuel shortages over the past decade have increased the demand for the #1 band of diesel fuel. Increasing demand has robbed #2 fuel of its quality, and the use of lower quality fuel leads to more diesel fuel system concerns than ever. That means greater care must be taken in the cleaning and maintenance of diesel fuel systems. Since the rotary pump operates in fuel oil and the inline pump is lubricated with both engine oil and fuel oil, the wear of these precision parts is usually negligible. The pump works perfectly unless dirt or water gets in. As little as 5 grams of such material in 1 gallon, or 25,000 gallons of fuel, can completely wear out a pump. So cleanliness of fuel delivered to the pump is essential in achieving long pump life. Another threat to the fuel system's precision parts, besides dirt, is water in the fuel. Now, this water may be good for you and me, but it's murder on the fuel injection pump. Water corrodes and rusts finely engineered working surfaces. The effects of even the smallest amount of water in the fuel injection pump can be just as disastrous as those of dirt. Water causes corrosion, which can result in rapid wear and even pump seizure. So when diagnosis shows that damage is occurring from water and dirt, speak with the customer about his fuel storage and handling methods. Usually the cause is poor storage facilities, careless handling, and condensation in fuel tanks. Proper handling starts by making sure the fuel supplier delivers fuel that meets the proper specifications. You'll find these specifications in the Trac Com manual with this video program. Another tip for proper handling is to reduce condensation inside fuel tanks by always keeping storage tanks full and by filling the tractor's fuel tank at the end of work every day. Also, don't permit water to accidentally spill into the tank. Keep storage tanks and fuel containers clean and covered to protect them from dirt. Angle the storage tank so sludge will settle below the fuel. Check the Trac Com reference manual with this video program for more information on how to set up a storage tank. Refuel using a hose with a clean nozzle and a filtered funnel. Set the tank cap down only in a clean place. A dirty cap is how most contamination gets into the system. The fuel supply system should provide unrestricted clean fuel from the tractor fuel tank to the injection pump. A basic fuel system consists of the fuel tank, main filter, fuel injection pump, and fuel injectors. Other components, such as a sedimenter, agglomerator, or fuel lift pump, may also be included in the system. On Ford's 6-cylinder tractor, the sedimenter or pre-filter is standard equipment. This filtration unit separates water and large contaminants out of the fuel. Separation is done by sedimentation. As fuel flows radially toward the center of the unit, dirt and water settle into the bottom. Clean fuel exits the top. On tractors using inline fuel injection pumps, a fuel lift pump is placed in the system to draw fuel from the tank to the injection pump. The pump is positioned in line prior to the main fuel filter. The primary or main fuel filter is fitted as the final filter in the feed system. Paper filter elements within the filter unit are designed to remove damaging contaminants that may be present in the fuel. Kits are available to convert the primary filter to an agglomerator. The agglomerator then combines features of efficient fuel filtration with water separation and collection. As fuel moves downward through the filter element, solid particles are trapped and fine water droplets are forced through the pores. They cluster or agglomerate in the base of the unit. The major component of the fuel system is the fuel injection pump. The pump sends fuel under pressure to the fuel injector. An inline pump employs 1 pumping unit per engine cylinder. The rotary pump utilizes a single pumping unit, regardless of the number of engine cylinders. Fuel is fed to the correct cylinder by a distributor rotor inside the pump. Now here's how a typical rotary DPA pump operates. Fuel pressure, controlled by a regulating valve, is raised by an internal vane pump. When the metering port and charging port align, fuel is passed to the rotor and pumping plungers. The quantity of fuel is controlled by the throttle lever, which acts upon the metering valve. As the rotor rotates, fuel is isolated inside it until the distributor port aligns with one of the outlet ports. The cam lobes bring the plungers quickly together, and the pressurized fuel is passed to the injector. The whole cycle is repeated once for each engine cylinder per pump revolution. Injection timing is controlled by the advanced piston. The second of the 2 types is an inline pump. The inline fuel pump also delivers a controlled quantity of fuel under very high pressure to the injectors to suit all engine load and speed conditions. This is how the pump operates. The inline pump employs one pumping unit per cylinder. The size of a pump is determined by the number of pumping units. Each pumping unit consists of a pumping element, which is a barrel and plunger assembled with a non-return delivery valve into the pump body. Spring-loaded plungers are operated by roller-type tappets acting on the camshaft. At the bottom of the plunger stroke, fuel from the fuel gallery enters the pumping element. As the camshaft moves the plunger up, the leading edge covering the inlet port isolates the fuel above the plunger. The fuel is then pressurized by the continuing upward movement of the plunger and pumped into the injector. A fuel injection pump delivers fuel under pressure to the fuel injectors. The injectors spray the fuel into each engine cylinder. To do this, they are constructed to fine tolerances. Each injector is a spring-loaded valve operated by fuel pressure. It introduces accurately metered quantities of fuel into the combustion chamber. The finely sprayed fuel mixes rapidly and completely with compressed air for efficient combustion. Injectors are manufactured to tolerances as small as 1.5 microns. Considering these tolerances are much smaller than a human hair, it's not surprising that even the tiniest particle of dirt can alter engine operation. The two major parts of an injector are the nozzle and the nozzle holder. Fuel is injected through the nozzle into the combustion chamber. The nozzle holder positions the nozzle and permits the assembly to be fitted into the cylinder head. Here's how it operates. Fuel enters the injector and gathers in a chamber surrounding the nozzle valve. On the fuel pump injection stroke, fuel pressure instantly rises above the preset spring pressure that opens the valve. The pressured fuel sprays out of the holes in the nozzle tip. Fuel pressure rapidly falls. The spring returns the valve to its seat, cutting off the fuel spray. When a concern does develop, good diagnostic procedures will help avoid unnecessary work and expense. To help demonstrate some techniques for diagnosing a fuel system, we'll rejoin our friend who will approach the situation in a different way.
Sure is, Frank, but it'd be a lot nicer if my tractor had some power.
Having power problems, eh?
Yeah, doesn't seem to be able to pull the way it used to.
It's been doing that long, Jim?
Oh, just
When a
about
customer
week
reports
now.
a fuel system-related concern,
looked at your fuel
try to
bill?
get a clear
Yeah,
understanding of the
just
problem
changed
from
that,
the customer.
Tuesday.
Do this by
any
asking
difference
specific
with the power?
questions about the concern.
What kind of equipment you pulling, Jim?
Oh, just my 416, but it doesn't seem to matter what I pull.
Well, where do you get your fuel?
Same place I've been getting it.
Have the same problem with the other tractor?
Oh no, it's running just fine.
Confirm the reported problem by operating the equipment. Begin with a complete inspection of the fuel system, including the air cleaner and fuel filter. As you do this, look for evidence of dirt or water in the fuel. The manual that comes with this videotape contains a troubleshooting guide that will help you determine the cause of the fuel system concern. Here's an example of a few problems that you might experience. Low engine power complaints should be confirmed because variables outside the engine and fuel injection system could be the cause of the complaint. A PTO dynamometer is very useful for determining power levels and causes of low power. It's used as a loading device to simulate field conditions. Without a dynamometer, duplication of engine loads for diagnosing complaints in the shop is virtually impossible. While testing, consider factors such as variations in cylinder pressures, improper intake valve adjustments, or even a restriction in the exhaust system as the cause. A check of these areas might quickly isolate the cause of the problem. When a tractor doesn't develop full power, a visual check should be made of exhaust emissions. A detailed smoke diagnosis chart included in the Trac Com manual with this video program can help with the diagnosis. Black smoke could be evidence of one of the following possible causes. A restricted air intake may be the cause. The engine could be overheating. Check the cooling system. It could be improper pump timing, low compression, or incorrect engine timing. Poor performance from injectors will also cause low power and usually blackish smoke. If the engine isn't developing full power and the exhaust is free of smoke, look for these possible reasons for the problem. An improperly set high idle no-load speed adjustment, restricted or leaking fuel lines, or low lift pump pressure. There also could be air in the system. Use the clear plastic tube that comes in the lift pump gauge kit, number 2843, to check for air leaks on the suction side of the system. Again, pump timing could also be causing low engine power, even if no smoke is evident. Low power with clear smoke may be caused by incorrect engine timing. Check the engine compression and the valves. When an engine is hard to start, the cause could be a blocked fuel filter, or water in the fuel, or improper pump timing, or low cranking speeds, or a malfunctioning starting aid. There also could be air in the system. The cause may be weak engine compression due to the poor condition of valves or piston rings. Look for sludge in the fuel tank. If sludge is present, drain and clean the fuel tank. If the engine won't start at all, the fuel injector pump may be seized up. If you suspect that's the case, there's an easy way to find out on the rotary DPA pump. First, remove the line into the pump inlet. Inside, some fuel will be visible in the inlet. Now turn the engine over and observe the inlet. If the fuel is sucked in, the pump is not seized. If the fuel remains, the pump is seized and should be removed immediately. Also test the inline pump for freeness of movement. To do so, remove the inspection cover. Turn the engine over and check the control rack and the pumping plungers to ensure they're moving freely. The shutoff control must be in the engine off position for both tests. Complaints of fuel leaks should be confirmed with the best leak testing procedures available. For example, black light testing. Lucas records show that a number of inline injection pumps are replaced when only the fuel lift pump is defective. These injection pumps could have seen continued use by replacing only the lift pumps. A special lift pump gauge kit, number 2843, is now available and should be used prior to replacing the entire injection pump. The procedure for using the test kit is to first turn off the fuel tank shutoff valve. Then remove the pulsator cover from the lift pump. Look for dirt inside the pump chamber and wash it out with fuel oil if necessary. When the cover is reinstalled, connect the pressure gauge and tube assembly at the fuel pressure line on top of the lift pump. Turn on the fuel tank valve again and pump up the lift pump until the pointer on the gauge rises to its maximum level. Observe the gauge reading. Pressure should be a minimum of 2.5 pounds per square inch. It should hold at that pressure for 5 minutes. If it doesn't, install a new lift pump. Winter brings another serious concern to a diesel fuel system. It's caused by wax. The wax separates or precipitates out of diesel fuel when the ambient temperature drops below the fuel's cloud point. The wax collects anywhere there's a restriction in the fuel line, particularly fine gauzes and filter elements. Fuel lines block up and starve the injection equipment. The engine stops or refuses to start. For engine performance all year round, in all types of climates, fuel heaters may be used to keep temperatures above the waxing point. Also, tractor owners should change storage tanks to winter fuel before the cold weather begins. Fuel filter elements should be replaced at the beginning of winter to minimize waxing problems. In severe cold weather, be sure the operator lets the engine warm up before starting off in the morning. These steps will help prevent clogged filters due to waxed fuel. Fuel injector pumps must be serviced with very specialized equipment, but there are some tasks that can be performed in the field. It is important to note, however, that when reinstalling a new or rebuilt rotary pump, the pump should be rotated clockwise 1/2 a division relative to the 0-degree mark on the rear of the engine front plate. This will eliminate the effects of timing gear backlash. The timing for an inline pump is checked as follows. First, remove the flywheel timing cover. Turn the engine crankshaft clockwise until the number 1 cylinder is on the compression stroke and the correct flywheel timing mark aligns with the arrow by the timing aperture. To eliminate backlash in the timing gears, be sure to turn the crankshaft clockwise. Next, drain the coolant from the radiator and detach the bottom radiator hose. Then, remove the timing cover from the engine front cover. Look closely at the timing marks on the pump drive gear adapter. See if they align with the marks on the pump body. If the marks are misaligned by more than 90 degrees, the number 1 cylinder is on the exhaust stroke. Turn the engine over 1 more revolution to realign the timing marks. If the timing marks are only slightly misaligned, the pump to engine timing must be readjusted. You might also find that there are no marks, or that the marks just won't line up. If that's the case, check the spill timing of the pump. Instructions for spill timing are included in the manual with this program. When you find the pump is properly spill timed, it can be retimed to the engine. Do this by turning the engine over by hand. Align the marks. Then remove the 3 gear to pump bolts and the adapter plate. Next, rotate the engine again until the flywheel is at the specified point. Then, with the marks aligned and the flywheel in the proper position, reinstall the adapter plate and the 3 pump to gear bolts. Torque the bolts to specification. Also, when installing an inline injection pump, a special tool, New Day number 1436, is available to hold the injection pump delivery valve holders. Use it while tightening the line nuts to prevent damage to the holders. The tool fits all current and previous model tractors. On 4-cylinder and some 6-cylinder tractors, the injection pump oil level should be checked every 50 hours and changed every 300 hours. The oil should be level with the bottom of the level plug opening. Injectors should be cleaned, tested, and adjusted every 600 hours. The procedure requires that the injectors be removed. When injectors are removed, always begin by cleaning dirt and other foreign material from the area around the injectors. When the area is clean, remove the leak-off lines and injector lines. Be sure to cap the lines to stop dirt or foreign material from entering the system. While the injectors are out for service, cover the cylinder bores to prevent entry of dirt. Also, discard the cork dust seal and copper injector seal washers. Clean the outside of the injectors with a solvent and a soft wire brush. When they're faulty, injectors require complete disassembly, cleaning, and reassembly. The procedure is described in the repair manual. However, no attempt should be made to overhaul the injector until it's been properly tested. The bench pop tester is capable of performing a variety of tests and is generally used in the service area. The portable pop tester may be taken into the field to check leakage and pressure without removing the injector from the engine. Use the bench tester by first testing the calibration of the gauge. To do this, install a master injector on the tester. The known pressure of the master injector will help you determine if the gauge is out of calibration. The master injector should also be used to check leak-off time of the pop tester. This verifies that the tester hasn't developed any internal leaks. Once the tester is ready, begin with the nozzle opening pressure test. Install the injector to be tested. Then pump the tester. Use slow, even strokes to avoid disturbing the gauge calibration. Read the pressure on the gauge when the nozzle pops open to spray fuel. In this test, the nozzle opening pressure should be as specified for the injector used. Do not attempt to pump the tester past the maximum gauge pressure. If the nozzle doesn't open at the specified pressure, it needs adjustment or cleaning. To adjust the nozzle opening pressure, remove the cap nut. Tighten the spring adjusting cap to increase pressure. Loosen it to decrease pressure. If this adjustment fails to allow the nozzle to pass fluid at the specified pressures, a complete injector overhaul will be necessary. The next test is the spray pattern test. The gauge valve should be shut off at this time. The nozzle tip has 4 small holes. Each hole provides its own spray pattern. To check these patterns, pump the tester rapidly to obtain a continuous spray. Observe each of the 4 spray patterns individually. The spray from each hole should be well atomized. All 4 sprays must be similar in shape. They should be spaced at approximately right angles to each other in a horizontal plane. Each spray should be shaped like a cone and spread into a 2-inch diameter circle at a distance of 6 inches from the nozzle tip. The next test is the check for nozzle seat leakage. Wipe the nozzle tip dry with clean blotting paper. Apply a pressure equal to 150 pounds per square inch, less than the nozzle opening pressure. Hold this pressure for 10 seconds. Apply a piece of blotting paper to the tip of the nozzle. The resulting oil stain should not exceed a diameter of 1/2 inch. If the leakage exceeds this, the nozzle will require servicing. The nozzle leak back test requires that the tester be pumped to approximately 2,300 pounds per square inch. When this pressure is reached, allow the pressure to fall naturally. Record the time it takes for the pressure to fall from 2,200 pounds per square inch to 1,500 pounds. The time required for this pressure drop should not be more than 40 seconds nor less than 10 seconds. Less than 10 seconds indicates that the needle is loose or that there is dirt between the nozzle and the injector body. If the injector has passed all 4 tests, it may be fitted with new seals and reinstalled in the engine. Injectors which fail any of the 4 tests should be overhauled. The procedure is described in the repair manual. After injector service has been performed, all tests will have to be repeated before returning the unit to service. Even a new injector or nozzle assembly will need cleaning and rechecking before installation if it has been stored for more than 6 months. The New Day 3161 portable pop tester is used in the field to test injectors either on or off the engine. Remember, though, that excessive testing inside the cylinder can cause the combustion chamber to become flooded. The result is knocking or even damage to the engine during restarting. Details on performing tests with the portable pop tester are in the Trac Com manual accompanying this program. But regardless of the test you perform, it's important to remember to keep your hands away from the spray at the tip of the injector nozzle. The atomized fuel can penetrate your skin and is extremely dangerous. Point the spray into a suitable container. Remember also that the spray is extremely volatile. Don't smoke while testing, and keep the spray away from extreme heat or flame. Many tractor operators unknowingly destroy their fuel equipment in an attempt to develop more power. They do so using a technique called overfueling. Instead of decreasing cost, expenses are driven up. The reason is poor fuel efficiency, reduced engine and powertrain life, untimely downtime, and loss of warranty. So caution customers about the false economy of the practice of overfueling. Warn them of the damage that can result to their diesel equipment. Diesel fuel injection equipment is complex. The injection pump should be serviced only by specialists using the proper test and adjustment tools. Often pumps are returned with legitimate concerns, but the reports show many pumps have no problem at all. Other cases show the damage is caused by the introduction of water and dirt into the diesel fuel. The indication is that a more thorough diagnosis might have revealed the real cause of concern somewhere else. In that case, the exchange pump does not eliminate the concern. It's important to eliminate the real cause, or the same situation can reoccur again even after a new pump is installed. Certainly, that won't help keep a satisfied customer. So use this Trac Com video and the accompanying reference manual, which includes diagnostic charts, as a means to correctly identify diesel fuel system concerns. This diesel fuel system information will help service technicians build greater confidence with customers and help owners enjoy longer service life from their Ford tractor diesel equipment.
Good. If you have any more problems, give me a call.
Okay, but I don't plan on calling you for a long time.
Sounds good to me.